In order for you as an administrator of Linux to be able to administer the Linux operating system, you need to be familiar with the hierarchy. You know, it's very, very important. And you should be familiar with the default directory that exists on almost all Linux file systems. You know, there are some few differences between Linuxes, but there are file systems that we know that these ones or these default directories, they will always be there regardless of the operating system, the Linux operating system that we have. Okay. Now, having said that, not all Linux file system have a main page that you can read on if you want to know more about the file system. But if your Linux distribution shows that you can run man 7, then you say this, you see on my screen there, it will then show you this. It then says here name, layout of the file system. So you don't have to, you know, my approach to Linux, guys, is you don't have to know all the commands for Linux. You'll lose your mind. You'll go crazy. You don't want to cram or know all the commands. It is impossible. You know, sometimes it's just impossible. There are too many commands. However, it is important for you to know how to, if you want to read about a command, how to get help, where to get the manual, where to get documentation. That is what is important. You don't want to cram every command. It's not practical. So, for example, you know, these are we've got, as I said, we've got default directories among different distribution of Linux operating system. However, for you to be able to know what each directory or file system contains and the importance of that file system, you then run the command man7 hier for hierarchy. You know, then you then read, but I'm running this command at this moment from my Mac. Remember that Mac is Unix, so Unix and Linux are same family of operating system. So you'll see that this command actually runs on Mac. So just try it on your Linux. Not all Linux have got a manual for this, but some still have. You will see that it will then explain each files or directories that we say these are the default directories that usually you find among different flavors of Linux. You know, so now these file systems, let me go to my Linux here. Just give me a moment to log into my Linux. Okay, I'm logged in, and I hope we are not shocked what I'm typing, because we did explain the ways of logging in to your Linux machine. You know, you run SSH, then you specify the user, then you put an @ sign, then the IP address of that particular server that you're trying to log into, right? Now, when we are inside Linux, if I say you see that actually I might have, okay, you see inside Linux here, the manual has been removed for reading more about hierarchy, but it's fine. I showed you on my Mac, I can actually get that information. Let me do this. So if I say main7 is there. Cool. So to understand the organization of Linux file system, guys, the concept of mounting is very, very important. We deal with mounting. It's something that is foreign, sort of, to Windows people, because when we talk about mounting file system from Linux perspective, it's totally different. On Windows, when you plug in an external drive, automatically gets mounted for you and is given a drive letter, like maybe drive D, drive E, or so on and so on. But when it comes to Linux, now is totally different. We don't use file letters here to say drive D, drive E, but we mount a drive on a specific directory, right? Now, let me just go a little bit back. Linux file system, it's organized in a hierarchy, you know. The hierarchy is what I'm actually even showing you here. The top of the hierarchy of Linux, we have got what you call a root directory. This one here. The root directory, that's the starting point of our hierarchy of the Linux file system. Then other files, other directories, they will fall within the root directory. So whenever you see this / in Linux, it references the root directory. That is your first directory in your hierarchy. Very, very important. Other directories that follows, like the ones that I'm highlighting here, they will be within the root. You see, how do you know that they are within the root directory? It's because the first thing that starts here before we've got bin, it's a / to say / reference what? A root directory. Then it says this bin is within this guy, of which is a root directory. This directory as well falls within the root directory, and so on and so on. And we do have subdirectories as well that falls within other directories. They will have, I'll show you when we continue and we deep into what we are talking about here. So now I just want to touch few file systems that are very important. So I'm going to remember the cd command, right? Cd stands for change directory. We change directory to our root directory. And when I say pwd to print the current working directory, it says I'm inside what? I'm inside my root directory, right? When I'm inside the root directory, then I list with ls command. These are the files and directories that are inside our root directory. So you will see there, if I do a long listing of my files and directories there, you will see that actually I've got almost all of them here are directories, except the first one, it's a link. The last time I know that I touched this, even though I was rushing, this one is a link as well. But I said that your first character in your long listing here, if it starts with D, it means it's a directory. If it starts with dash, it's a file. If it starts with L, it's a link. I hope you still remember. And I said if it starts with C, it's a character file, right? So you see that I am inside my root, meaning this is the parent directory for all directories in Linux, it's our root directory. It's the first directory in our file hierarchy. Now, when I'm there, we then have different other directories here. Now, let's start with boot directory. If I change the directory and say go to the boot directory, you see that it has got some files here. You don't have to understand these files now, what they do. But one thing that you need to know is inside the boot directory or boot folder, but remember I said in Linux we call them directories. We have what you call, this is a boot directory. Boot directory contains all files and directories that are needed to boot to Linux kernel. Okay? It contains all files and directories that are needed to boot the Linux kernel. So when time goes on, you will see that this thing that starts with VM Linux, it's actually the kernel image. This kernel image is the one that gets loaded when your machine starts. And you will notice that we have got something that starts with init-rem here. Init-rem is very important during the boot process as well. And we'll get to talk about all these things when time goes on. And yes, so these files that you find under boot directory are very important for booting the Linux kernel, guys. Fine. Now let's go back one step. To go back one step, it will be cd dash dash. Cd dash dash is good to go to the previous directory. Now when I'm there, when I do long listing again, I've got my directories again. We spoke about this one. Let's talk about bin. Let's go to bin. So now when we get to bin, it lists lots and lots of files here. Now these files, most of them are executable files. These files are executable, meaning you run them, you know. Most of the things that we run on Linux, these are the commands that we run are sitting in here, right? So all these things that you see in the bin directory are needed to repair the system in the minimal troubleshooting mode. If you go to the if you go to let's say your machine is not booting, something is wrong, then you go to the what do you call this, emergency mode, you know. It will load this, it will make sure that this directory and its files are accessible to you, because you need the files that are under bin directory for repairing your system in a troubleshooting mode. So now let's see something here. So you will see, actually, if I say ls, there is a ls command is sitting in this directory. Now, if I say there's a command called which, right? Which is a command that we use to find where in the file system is this command ls is sitting. So we know that ls command is actually saved under bin ls. Here, bin, it's ls is under bin, you see there. So I could use along I could run ls this way, you know, and it will run. However, there is no need for me to do it that way, because you remember when we started, I spoke about the path variable. You remember the path variable. You will see that the path variable, we use it if we if we want to run a command, even though we are not in the directory where that command is sitting, because this path variable will then automatically search for that particular command that I run in the listed directories here. You see that these directories are delimited by a colon. See, so we've got this, we've got that, we've got this and this. You see, the reason why when I run command, regardless of where I am in my file system, and it's able to execute the file called ls, is because the path variable has got bin as one of the directories that it needs to search when I run ls. Fine. Now, we spoke about bin. Now, let's talk about another one. Let's go back there and say long list. And we've got dev. Let's go to dev. In here, these are the device files that are used for accessing physical devices, right? Your physical devices, you access them by getting into this file, right? This file is very, very important during boot time. Let me do this. For example, in this Linux of mine, I've got few disks that are attached to my operating system. But for me to access my disk, I access it by using a file that is referencing my disk, and that file will be inside a dev directory. It will be inside the dev directory. And the dev directory here now, you will see now my disks are referenced using this naming convention, xvd something. So just to see that, let's just say anything that starts with xvd something, you will see that I've got these files here. So when it says xvda, xvda1, xvda2, this is a one disk having two partitions. xvda1 its first partition, xvda2 is the second partition. Then I've got another disk here called xvdf, and it's not partitioned. Nothing is happening on it because it has got no xvdaf1 or so. So this disk is not partitioned, but it's a disk. I've got a disk called xvdg, and I've got xvdg1, meaning this is the first partition in my disk. So dev, the directory contains it contains files that are referencing physical devices, not only disks, but today I was just showing you example by referencing a disk, but there are many other stuff that you can check in here that have got files in here, and those files are referencing a physical device. Okay, now let me just show you, let me see something here. Standard error, it's a file. Just give me a moment. Just to mention something that we touched the last time, I said to you guys, you remember when I was talking about file descriptors, I said to you, we've got three standard IO streams, right? We've got the first IO stream, which is a standard input. We've got standard output and standard error. Standard input will be more or less like your keyboard, right? Where data or information is received. Your keyboard will be standard input. We have got standard output. The example of standard output will be your screen, where the output is put there for you to be able to see it. We've got standard error, where the error are streamed. If there's an error that is produced maybe by an application or something, if you want to channel that error to a file or to your monitor or wherever, you will then reference IOStream this file descriptor 2, right? I hope I'm still making sense. I'm not, it's not complicated at all. So now, when we are inside dev, I want just to reference this and show you. We have got files here called standard error, standard in, and standard out. Standard error, standard input, standard output. You will see that actually these are referencing here file descriptor. Remember that FD stands for file descriptor. So you will see that standard error is referencing file descriptor 2, standard in is referencing file descriptor 0, and standard output is referencing file descriptor 1. I even went as far as showing you example by streaming the output of my command to a file or maybe to my screen. So remember that. We find that under dev directory. These directories are very, very important because these are default directories irregardless of the Linux distribution that you use. You will find these directories among different Linux. Fine. Now, let's go back and do listing again, long listing, and let's go to another directory that is interesting called etc. etc. If you are inside there, you will see lots and lots of files. You know, there are many files in here. These files and directories are very, very important, guys. The etc directory contains configuration files that are used for programs and services that are used on your server. You understand that part, right? So all the configuration files are in here. Configuration files for your programs, for your service, are all stored under etc. If you install, let's say now you do yum install. Yum command is used for installing. If you don't understand it now, don't worry, we'll get there. So let's say I say yum install. What can I install? Let me install DHCP. If I install DHCP, okay, it says it's already installed here. So now when I'm inside etc, I can actually go to DHCP, and inside DHCP I will find configuration files of DHCP. I'm just making an example with DHCP. You'll see now it says dhcpd.conf. .conf means configuration file. If I were to check what is inside dhcp.conf, you will see that at this moment it's empty because we haven't configured DHCP, but it says DHCP server configuration file. That's where we find the configurations of your services and of your programs. Now, I will touch one more directory, then I continue. I don't want to spend too much time on this, but I felt like I needed to talk about them. So now let me go back twice. So now I'm still in my root directory. We have got a file here. We spoke about that. We've got this one here. Where is it? We've got var. Var is very important. Var means varying. It varies. It's one file system that you cannot be sure how big it will be. It varies. Today is 2 gig. Tomorrow it's more or less like still on the same size. Sometimes it grows very fast. Sometimes it's not growing that fast. You can't really tell at which rate it grows and all those things. It varies, it varies a lot. That's why it's called var directory. The var directory, why it varies so much is because it contains the log files. It contains the log files that are generated by your programs as they are running. If they encounter a problem, a warning, and anything that they want to log, they are logged under var directory. So sometimes, for example, you go to your program and you enable debugging mode. Debugging mode, it will then spew a lot of information about what the program is doing. That is very important for troubleshooting purposes. However, because of generating so much information, the var directory will then get full very quickly. But sometimes you then disable your debugging mode on your application and it's no longer generating too much information, and your var is no longer growing at rate at which it was growing before. So as a system administrator, this directory, you'll be working on this directory a lot. Let me go to you will see that my working directory is var log. In here, that's where the logs are kept. There is a most important files in here. The one that you most probably will work with would be where is it? The message file. The message file is more like a default file where the errors and whatnot logs are kept. But other applications, they will have their own file where they keep the information. Like, for example, in here I've got an application called Squid. If I go to Squid, Squid will have its own logs separately in here. It does not want to log its logs under messages, but message will be the default file that is used for logging, right? And you will see that if I just want to show you something. If I say, not less actually, let me say cat to print the output of the message file, you will see that is very big. So this file system is very, very important, guys, to system administrators. So, okay, I see that you guys, yeah, okay, you tested on CentOS. Thank you very much. If it's still the same, that's good. That's good. So, let's go back again to our root, the directory. When I'm there, I will do long listing again, and I'm here. We spoke, so I just want to touch the most important ones. We've got here opt. Opt will be your additional programs that will be saved in there. Then we have got home directory. Home directory is as you create new users and they log in, the directories that are associated with that with the directory that is associated with that user will be created. If the user is Tieho, will have a directory called Tieho in there, and in there it will have all the files of Tieho. So Tieho, if he has got files in here, those files, Tieho will have full access to his files, and and directories that he has. So what else? We spoke about etc, we spoke about dev, we spoke about boot, and there's a temp file system. There is another one called temp. Others will find them when we say tmp. Okay, temp is here. Temp file directory, it contains temporary files and directories. When you reboot, they are gone. You reboot your machine, they are gone. So they contain temporarily stored files and directories. Okay, fine. We spoke about boot, we spoke about etc, we spoke about home, opt, we spoke about temp, we spoke about vacuum directories, and I hope we are still continuing and we are all following. No one is lost. If you are lost, please tell me now. Okay. Okay, Ati, you want me to explain? You say inside the root directory, you see a directory called root. That root directory is a home directory of root user. We should not confuse the root directory hierarchy and the root directory home directory. This is the root that you see here that you're asking about, this one here. It's a root home directory, and this root home directory is a subdirectory of root directory, and our root directory, remember, is this one, the /. This is our root directory. Linux is structured in a way that it's a hierarchy, and the top of our hierarchy we have got root, right? And inside root directory, then we have branches that are branching out. We've got home directory for normal users. We've got a home directory for root user, and the home directory for root user would be your root. The root home directory does not stay in under home. Only the only the home directories of normal users are under home directory. I hope I've explained that one. Okay, I'm just gonna assume that you are happy with the answer, and I will continue. Now, remember what I said, guys. I said a Linux file system is presented as one hierarchy, right? With the root directory as its starting point. On top there, we've got root directory, and remember our root directory is represented by /. And our root, then our hierarchy. Remember now, the hierarchy of Linux consists of these default directories that I just explained that you see here. And these directories that you see here, they can then be spread across different devices. That's the nice thing about Linux, something that I don't think is there on Windows. You can spread the hierarchy. Sorry. You can distribute this hierarchy of file system across different devices. That's the nice thing about Linux. For example, I can have 2 disks on those two disks, I can then bring them together and spread these file systems that we are speaking about here, talking about here, across two disks. You know, it's more like what in Windows? It's more like saying, remember that in Windows, your operating system files are stored in one directory. They are all under C drive, right? They are all under C drive. And that C drive is sitting on one disk. But in Linux, all these directories that I'm referring to, that I'm talking about with you today, they all make these are the most important directories for the operating system to function properly. However, they can be spread across different devices. It's like now on Windows, I'm saying I don't think it's possible on Windows. It's like on Windows saying System32 will be sitting on drive D, and what do you call that other one? X installs in C drive are no longer in C drive, are now on drive E. It's not possible. Windows won't even be able to boot. But in Linux, we are able to distribute the operating file systems that are very essential for the starting of the operating system across different devices. That's the nice thing. And there are many, many benefits of that. Now, let's talk about few of the benefits. Let's compare this with Windows. On Windows, if C drives gets full, it affects everything. It affects home directories. It affects your applications that are installed, if they're installed on your C drive. Even if they're installed on D, if C becomes full, sometimes it becomes a problem for the operating system to function, you know. So your C drive, if it gets full, you're screwed, you know. But now let's talk about on Linux, where your file system can be distributed across different, even partitions, you know. They can be distributed across different devices or different partitions. For example, if I take, for example, home directory and say the home directory will be sitting on its own disk or on its own partition. Even if Tieho comes with movies at work and we are using Linux at work and we are sharing this Linux machine, and for some reason Tieho fills the home directory, that home directory won't affect the boot directory. That home directory won't affect the other important directories because they are separate. Are we together? Now, let me make another example. On Windows, if it happens that the file system, for some reason, or operating system crashes and is no longer booting, nothing happens. Like you cannot boot this file system, the operating system again. You do the reinstallation of your Windows machine. You cannot say, I am choosing not to format my home directory. I only want to replace things except my home directory. You know, it's not possible. But on Linux, because these things are sitting, you can configure them in such a way that they're sitting on different devices or different partitions. Or you will see when we get to Logical Volume Manager, they can be sitting on different logical volumes, you know. When I then say my Linux is no longer booting, my Linux is somehow it's no longer working. So what I can I can reinstall my operating system without losing data that is under home directory. I can just reinstall. Then automatically I just choose when I install the don't remove home directory. It leaves the home directory as is. You know, that is one of the benefits of having your important directories for the operating system spreading across different devices or different partitions, right? Now let's talk about another scenario. Let's say, what do you call this thing? Security. The security comes and the auditors comes and say, a home directory cannot have same security rules as your boot directory. A boot directory has to be read-only. No one has to be able to edit anything under boot. But as for home, it's fine. We can have read-write. Now, because I am using Linux and my directories can be separate, I can then apply security rules on each directory separately without affecting the other one. I can apply a security rule on home directory without negatively impacting the boot directory. I can play and say, for example, you will see when you progress in your Linux that there are times where you will have to do OS hardening. When you harden your operating system, maybe the company is being audited, then they tell you you have to make sure that you harden your OS. So now what will happen is this. Okay, what will happen is this. They will tell you here that you cannot be able to execute or run a program from a temp file system. You cannot be allowed. It's a security risk for allowing files to be executed inside the temp file system, right? So they will tell you, if you go to TMP, if I now, for example, if I create, let's say, something here, let me say, I create a script. This script runs df-h. It's another command. And if I say change chmod for changing the permissions, and I say I make this thing 755, don't worry if you don't understand 755 now and chmod, but you will get there. We are not there as yet, but I'm making this file executable. Then if I run now this file here, it's executable, because here we see that it's actually managed to execute and return the results of the command inside my script. But you will see that for security purposes, they will tell you this should not be allowed. Then that's where now you then you will then have to mount that file system with an option of no exec, meaning it cannot be executed. Okay, let me see why. Okay, it's not in here, but when time goes on, I will just show you guys all these things that I'm talking about. I'll show you guys. Just give me a moment. Just check something here. Where are my glasses? Ah, now I see better. Oh, I can see this. Okay, I will have a look. It's fine. But this is one of the benefits of spreading your file system across multiple devices. And in the traditional storage space, if a disk is full, it affects everyone else and other directories. But here, if you plan your things correctly, if one file system is full, it does not affect the other. Cool. Let's move on. And I think I made it clear that if home directory is separate, a home directory can survive a reinstallation of the operating system. Okay? There is a command that I want to talk about. It's called find mount. Find mount. Find mount command. Come on now. Find mnt. It will show you the file systems that are mounted, where the source, the type of the file system, and the options that are mounted with. You know, if you see RW is read write, RO is read only, and other, when you see like no exec, meaning you cannot execute anything inside this file system, you know. So when time goes on, we will learn more about all these things. But this command is very useful when you want to see where what is mounted. If you want to see, okay, this is mounted here, that is mounted there, and all those things, you use find mnt. It works hand in hand. Another command that does the same thing is called mount command. However, this can return things in a way that is a little bit confusing, but you will see that what is here is exactly what is here. This command show it in a nice way. This one is clustered, you know, you might not be able to see exactly what's happening, but these two commands are actually returning the same thing. So I would recommend that you use find mnt. Okay, and now, because now we are working with what you call this, with disks, remember that your directories are sitting on the disk, and as you create more directories and you are creating more files, your disk can get full. So how do you even check your disk if it's full or what? You run df command. The df command will then show you the file system. It will show you, okay, this is the file system, this is what is used, and this is what is available. The use is 50%, right? But this can be confusing. You can then use -h for human readable format. If you do that now, it puts them in gigabytes. Say the size is 10 gigabyte. I use 5 gigabyte. I'm left with 5 gigabyte, and I use 50%. And you will see that in this Linux operating system, everything has been put under one hierarchy root. It's not spread across different devices. It's not spread across different partitions. It is not spread across different logical volumes. So you can say this can be somehow a risk. If I run out of disk space here, it will affect everything. However, one day I will touch on this thing, but yeah, be careful when you create your file system. Make sure that you are able to resize it very easy in case of one of the file system gets full. And when it gets full, it does not affect the other file systems. Now, in Linux, we have got different file system types. File system types, I want to make it clear, because I know many people are familiar with Windows. Let me make an example with Windows. On Windows, we have got I think I know of 3 file system types. I know of FAT32, I know NTFS, I know NTFS 32. I think I know those two. But when it comes to Linux, you have got lots and lots of file system types that you can choose from. And each file system type has got its own advantage and disadvantage. So if you want to know more about the advantage and disadvantage of file systems in Linux, I would recommend that you go to Google and search. And so the quick way of finding the file systems that are supported by default in your Linux, you will see that in my Linux here, I ran a command here, fkfs, then I just double tap to show me the file systems that I can choose from. You'll see that I've got about 2, 4, 6, 8, 10. Now, I can choose either of these and format my disk using one of those file system type and be able to mount and be able to use that file system right away. Okay, and as I said, on Windows, if there are not 2, there are 3, but they are not as many as the ones that we find on Linux. And as I said, each file system type will have its own disadvantage and advantages over the other. Now, you are working on a Linux where the disk is already formatted, and you want to know which file system has been used, which file system type is used to format that specific directory, that specific file system. You run df-h and capital T there, df-h capital T. It will say type. You will see that the file system type, you will see that this one is XFS. You know, XFS is a very good file system. Go and learn more about XFS. You'll see it's very, very good. Now, you will see that if you have a file system that you were using on Windows, or a disk or a external disk that is formatted by using NTFS so that it can be mountable, that can be usable on Windows, when you bring it to Linux, when you mount it, you'll have to be specific and use a what do you call this thing? An option called CIFS. CIFS, it's a Windows file system. So when you do, you will say mount -O for options. Then you say, no, I'm lying. -T for file system type. Then you do this, and then the device and where you are going to mount your file system, right? So the CIFS is referencing the Windows file system NTFS. Cool. We now know how to check the size. We know how to check the file system type, the total, the used, and where it's mounted, right? We know that this disk, partition 2, remember I spoke about it. If you see 2 here, my disk is the first disk because you see A. This is the first disk in my Linux. Partition 2 is mounted under root directory. So this is in a hierarchy of our root file system, this is our first hierarchy where everything branches out. Cool. Now, because everything in Linux, you will see when you go, we continue with this, you will see that in Linux, almost everything is treated as if it's a file. Everything. You see that, for example, if I want to access my disk, I have to go to a device file system. When I'm there, I showed you that my device, my disks are referenced as these ones. if I use this file, this is a file, okay? And this file reference an actual thing called a physical disk. But you see that the way Linux works with this disk, it works with this disk as if it's a file. So now it means working with files is one of the biggest tasks of system administrator in Linux. Now, meaning we need to be able to maneuver around directories and files very quickly in Linux. Now we need to learn about something called wildcards. You know, wildcards are very, very important in Linux. For example, I'm going to make a directory, right? I think we spoke about this. mkdir is to make directory, and I'm going to call this directory African Linux. Oh, it exists already, so I've created it before. So I'm going to come in here. If you see, if I say print working directory, you see that it's this one. Print working directory. I'm under root African Linux. Remember, Ati, I said to you, root here, it's a home directory of root user. Don't confuse it with root directory for the hierarchy of file systems. Okay, and when I'm here, I just want to copy stuff, you know. CP command is used for copying. So I want to go and copy anything that starts with A, B, C, D and is followed by any character into this file. Okay, now you see that my you see that in here now I've got files that starts with A or B or C or D, because when I was copying, don't worry if you don't understand, we're going to come to that point, you understand. But I just copied all the files that starts with either, let me put my command again. I'm copying from this directory, I'm copying files that start with either A or that starts with B or that starts with C or that starts with D, and they're followed by anything. You know, I don't care about what follows. That's why it's A blah blah blah, A liasis blah blah blah, A auto fs, auto.net, bash rc and all that. Okay, and the dot is the current working directory. So copy all the files that I have specified into my working directory. That's this dot here. This dot here. And that's why now when I say long listing in that directory, you see this file I can print, you see I'm African Linux. Cool. Now that I've done that, let's say now I want to, okay, the wildcards. I wish I had where I can write, you know, but I will fix that thing in the future. We'll have where I can write and you guys are able to see as I'm writing. I'll fix that. For now, I want you to know this. We've got wildcards, we've got this, we've got this, and we've got this, right? We call them wildcards, and we've got the one that I've just used. We've got asterisk, we've got question mark, we've got dollar, and we've got these brackets, right? And now these things, they mean something. Asterisk means refer to unlimited number of all characters. Asterisk as a reference unlimited number of characters. For example, if I say list all, it's going to list everything, because anything and everything will be listed because it's unlimited number of characters. I'm not saying list characters, files that are starting with these 2 characters or what. Okay, and let's say now I want files that let me see. Okay, let's see which one is there. You see this file here, dryrc, dryrc. What if I want to list using wildcards this file alone? I could do this. I can say ls anything that starts with D and has got 1, 2, 3, and C. Now, a question mark used to refer to one specific character that can be any character. It can be any character, but one. Now, if I put 3 question marks, I'm saying I want any character, but it has to be one. If there are 3, I'm looking for 3 characters. But they have to be between D and C. They have to be between D and C. But now, check when I use asterisk. Still returns everything. Remember the difference between the two. Question mark used to refer to one specific character that can be any character, whereas an asterisk refers to any unlimited number of all characters. You see? This one I don't have to say 3 times 1, 2, 3. Any, as long as it starts with D and it ends with C. This one is very specific. I'm looking for 1. For example, let me touch command you remember is for creating files. Let me touch a command called cat, and the other one will be quote, the other one will be cat, right? Now, if I do long listing, you'll see I've got cat, quote, and cat, quote, and cat, okay? Now, if I now say ls, anything that starts with C and ends with T, but I want one character in between. There must be one character in between, and it will return either cat, quote, cat, or quote. Are we still together? So this is wildcat. And now, what if I say ls anything that starts with C or D and followed by anything? You will see that it will print anything that starts with C or D. We see here, it will print anything that starts with C or D, because now in that bracket, that's where we now put the things that we want this thing to match. Now, let's make another example. Let's say, let me touch another file here and say, this file will be cc cat. So I've got double C. And if I now say list, let's see. Okay, this one probably, let me just check something. Just give me a moment. Okay. This one works with grep command. You will see that I'm saying list everything, then pipe the standard output of ls command into standard input of grep command. And after that, then I say I want to see only files that start with double C. So what you see inside here says whatever the character that I put here by 2. If I put 3 here, it will look for things that have got 3 C's. 1, 2, 3. Okay? I hope I make sense there. So these are called wildcards. Okay? And we worked with directories. Just for an example again, if I want to make a directory, I mkdir, I can create a directory called Tieho, and if I do long listing, you will see Tieho here starts with D to tell you that it's a directory. I can cd or change directory to Tieho and print working directory. You will see now I'm under root African Linux Tieho. So I created a file. I created a directory called Tieho. I then changed the directory into that to be my working directory. Then for creating files, you use a command touch. I can touch a file called Bogo. If you check there, if I do long listing, you'll see it starts with dash to tell you that it's a file, right? And a file, this file is got 0 bytes to show you that has no data inside. Now, let's talk about absolute versus relative path names. We have got absolute and relative path names. What is the difference between absolute path name and relative path name? Now, let me start with this. I've got a file there called Tieho. I'm going to go inside it. Didn't I touch Tieho? Oh, I touched Bogo. I've got a file called Bogo here. I'm going to go in it and type some stuff in it, you know. And I'm going to save it. Now when I say cat Bogo, you see it has got this. Now when I say long list, you see now it's no longer 0, but it's 56 kilobytes. It's 56 kilobytes. If you want to see how you see there, I can do this, you'll see. It's 56 kilobytes. Now, let's now understand the absolute path names and relative path names. An absolute path name is a complete path reference to the file or a directory you want to work with. It's a complete path reference. It's a complete path reference to the file or the directory you want to work with. Let me show you. I want to work with a file called Bogo, and file called Bogo is inside root African Linux Tieho, right? I'm going to copy that. Now I'm going to change the directory into this directory. If I say print the working directory, you will see that I'm no longer under that. I'm under my root directory here. But now, if I use a absolute path names, and I want to see what's inside my file Bogo, if I use the absolute, I will say root African Linux Tieho, then Bogo. I'm now able to view what's inside my file. How do you know that it's an absolute path name? The absolute path name always starts with root directory. The root directory is the first / before anything that comes before it. If it starts like that, it's an absolute path name. An absolute path name will always get you to the file that you want irregardless of where you are in your operating system. Now I'm in this. Even if I go to another directory, now I'm under home. If I use absolute path names, I will always get to where I want to go. I'll always be able to view or cat the files that I want to cat, or I can be able to change the directory to that one because I'm using absolute path names. Now, what is a relative path name? Now, a relative path name is related to the current directory. Now, let me show you. I'm going to go to root home directory. When I am here, there are a lot of files in here. My relative file name will be root. If I do this thing will be relative file. Okay, I think I showed you guys this. If I want to list my directories only, I said we run long list, then we grab anything that starts with D. Right. So these are my directories here, and in this directory, root this one here, this root will be a relative path name of African Linux, clone D, kernel, Python, squid, stress, because these ones are in here. And if I want to go into African Linux, I can just say cd African Linux, and you will see that when I say cd African Linux, it does not have the root file system here. It's empty here, and this is how you know that this is a relative file name, because it's relative to my working directory. It's relative to where I am now. You know, if I do this now, I'm inside Linux. I'm inside Linux, African Linux. I cannot use the relative path names if I'm not in a directory where African Linux is. If I now go to home and I try to say cd African Linux, it will say no such file or directory. So the relative file names will not always take you where you want to. They will depend on your current working directory. But the absolute file names, path names, will always, irregardless of where you are in your file system. So when you copy files, if I copy a file from, let's say, etc dscp something, and I then use an absolute path. If I use absolute, it will start with this. It will start with / you know it's absolute. And then I say root African Linux Tieho, and when I copy there, you'll see now it's copied. If I now go to this, is there. So be careful when you are copying files, when you are creating files and all those things. You know that absolute path names will always lead you to where you want to. But relative, they are relative to the current working directory where you are. Cool. I showed you a command for copying a CP. The command for removing is rm. It's not rename. I once made a mistake when I was still learning Linux, thinking this rm is for renaming. It's remove. If you run rf and you say boto, it will ask you, are you sure you want to remove this file? Like remove regular file boto. If you say y, it will remove it. If you say n, it won't remove it. However, let's say you are 100% sure of what you are doing, and you don't want to be asked the question, do you want to remove this file, you can run rm command with f command. That f command is false. It's not going to ask you anything. It's just going to deal with the file. The file is gone. The file is gone because we chose to false. So that's remove. We've got another command called mv. The mv command is used for moving. If I want to move this file called dscp.conf into my temp file system, I can run this command like this. If now when I go to temp, you will see now it's under temp, right? Let's move it back. Move dscp to Linux Academy Tieho, and we then change the directory there. It's here again. The very same command move can be used for renaming. We can then rename this to testing 1. Now when we it's now called testing 1. So move command can be used for renaming as well. Move command can be dangerous sometimes when now it's called temp. It can be dangerous sometimes where, let's say, let me see. If you want to move a file, let's say you want to move it to another directory, and you make a mistake, there's no directory called tempdsd, it will remove that file. It's gone. Oh no, let me see something. No, it's actually under, I put it here. It's here. But at the same time, I just wanted to say, just be careful when you use move command, because sometimes it can be a bit dangerous. So I'm going to remove this file. Say yes. Okay. Now we spoke about list command, and let me go back again to, I want to go, okay, now I'm back into African Linux. We spoke about long listing. It will list your files, when they were created, how big they are, they fall under which group and which user, and that's good. So another thing that you need to know of quickly, that is long listing. We've got another one. In Linux, any file that starts with dot, it's hidden. Let me show you. If I attach a file now and say dot testing hide, and I say list, long list, you won't see that file here. Anything that starts with dot is there, but it's not shown. If I now say go inside this file and let's edit this file, and let's just edit this file and we save it. If I say cat.testing, you see that there's got information, but if I say list, it's not showing here. You can check, it's not showing here. Anything that starts with dot is not going to be shown by default. It's hidden. But if you want to show even the hidden files, you then use -a. You see, when I say -a, it now shows here. If I want to do long listing and -a, you see it's here now, that file. So if you want to list the files that are hidden, you use -a, because anything that has got dot in Linux, it's hidden by default. If you want the command that shows you the modification to sort by modification date and edit date, recently modified, you use list long list rt. This one will then list based on when they were added, time and everything. You will see that the one that was added late will be the last one. This one has been here longer than the other ones, and this has been added recently. So this is a nice way of listing in order and sorting based on modification and date added. Now, when you sometimes copy, you use a command, an R command for recursively, because when you copy directories, you want to copy directories and what is inside directories, you use -R. I'm just rushing quickly now. If you now, let's say you want to list only directories, you can then use, let's say you want to list a directory called Tieho. You'll use -D, because if you don't use -D, it just does this. You see there. And Tieho is a directory, so you have to say -D, and it will show you information about that directory. What if you want to list at the same time, recursively list the things that are under that directory? Then you use ls minus capital R. Let's do a long listing. It will show you the things that are in here, the things that are inside Tieho as well. But at this moment, there's nothing under Tieho. So if we quickly go under Tieho and touch a few files, maybe let's say touch Tieho boto. Okay, I created Tieho 1, 2, 3 until 10, right? Now let me go back and now say list, long list, and capital R. It will show me everything and everything under directory called Tieho. You see here. You saw, so it's a recursive listing. Okay. We spoke about deleting files. It's RM. And now I'm going to close it here. Tomorrow, not tomorrow, next week, or Sunday, I will update you guys in time. If for Sunday we are having this discussion, I will tell you. Then we're going to continue from using links. We've got symbolic links, we've got hard links. I wanted to talk about them today, but unfortunately already I've taken too much time on this topic. With that, I'm done from my side. I don't know if there's anything from you guys that you want to share with me, but what I can say now is I've got a friend of mine that I work with, and is Mr. Mahlangu. He is working on creating documentation. So as we are talking about all these things, Mr. Mahlangu will be then making a documentation that will be uploaded to GitHub, and that documentation that will be uploaded to GitHub can be accessed by you guys here, and you can edit that file. If there's something that you feel like he left and you need to add, feel free to do that. So we are now starting to document everything that we do. Very, very important for us to document. And thank you very much for taking time to listen to me as I am teaching Linux. Thank you very much. If there's anything that you want to share with us, this is your time. Before I close this, please say something. It's nice to work with people who are showing that they are listening by asking questions, by contributing. I really appreciate that. Don't just sit there, and even if you don't understand something and you are just there, just say something. Can you please repeat what? Or I would like to add, just like what Mr. Mahlangu is doing there. You see that now and then tries to help by sharing the links and helping with the commands as well. And I really appreciate. Let all engage. It becomes more interesting when it's not from one person, but we are all engaging in this. So I'm giving you guys 2 minutes before I can close this session. Yes, I see that you are fixing the documentation. Thank you very much. I guess by Sunday or so it will be ready. So guys, I think you see that we are really, really serious about this. Please invite others and let's all engage. This is very important to us as well. Um, uh, you need to take the time of a person who's helping very serious, because we are preparing for exams as well. This side, I am preparing for Amazon exam and architecture, and so I'm taking this time to make sure that I'm sharing what the little that I know with you guys. So I would really appreciate if we take this serious, invite others, let's engage, let's help each other, let's grow and see ourselves going forward. Thank you very much. That's all from my side. We'll see each other next time.